2024 paper of physics, and we are not going to go through each and every question. Only where we have doubts we will start solving. Now this is your question number 1. This is your MCQ. The beam is pivoted at the end. uh, it has a force of 5 Newton acting vertically upward. Can you see this one? This is the pivot. So this is going to make it rotate this way. Okay, this force will make it rotate this way, and the weight of it is going to make it rotate this way. Understanding?
Yes.
They are saying that it is in equilibrium. Now remember, equilibrium means the moment due to this and moment due to this is going to be equal. Correct? So the weight of the beam ballast, let us say that is mgf. So m into this, okay? Remember your w1 l1 equal to w2 l2, yeah? So m into how much is this distance? 50 is equal
5. It's 2.0 and 2.3.
This is not 50.
No.
Okay, yeah, correct. There is a decimal point there, no?
Yes.
Okay. So m in, oh sorry, this one here. It's not 20 and 30.
It's 2 and
2 and 3. Okay, fine. And W2 will be this. This will be 5 multiplied by how much it is? 2.
2.
So 5 and 5 got cancelled and m will be 2.0. Where is 2.0? Understood.
Yes.
So your first one is this way. There's a forklift. A truck lifts the heavy box onto the shelf. Which action requires greater power output from this truck? Now what is the power output? Your power output is going to be work upon time. Correct?
Yes.
Which means if the time is less, then the power will be more. Agreed?
Yes.
The greatest power, so lifting the box from the ground slowly means time is going to be more, so power will be less. Lifting the fork from the ground to the high shelf. Now remember, high shelf is more work, low shelf means less work. Okay, so low shelf we cannot. Quickly means time is less. So where will be more power? B. Mechanical advantage of practical single fixed pulley. Practical fixed pulley, if it is ideal fixed pulley means mechanical advantage will be 1. But practical means MA will be less than 1. Where is less than 1? B. Fourth one. Which statement is true for all 3 types of radioactive emission? They are deflected. Gamma doesn't get deflected, so this is not true. They ionize the gases. They do.
Yes.
They are completely absorbed.
No.
By aluminium. No, alpha doesn't get absorbed. No, alpha gets absorbed, but thin aluminium sheet gamma passes through, right?
Yes.
So they emit light? No.
No.
So this is the correct one. They ionize gases. Only ionization means alpha is to beta is to gamma. You have to remember these numbers.
10⁴ is to
okay,
10⁻⁴.
so this is your alpha is to beta is to gamma is equal to this. You have to know these numbers. Okay.
Yes.
Object is placed
in front of a converging lens. The lens has a focal length f The lens produces a real enlarged image of the object in which labeled position is the object placed.
Okay, so there is a real enlarged image. Now remember, if it is 2f, if it is 2f here, then the image will be same size.
Yes.
And if you bring closer, then the image moves and becomes a real image, correct?
Yes.
So where is the object placed at B?
At B. A ray of light is incident on a glass air surface. The diagrams show the ray of light at different angles of incidence in the glass. What is the critical angle for the glass air surface?
This will be where it is 90 degrees. So this will be your critical angle, correct? That is B.
A student claps once when standing 100 meters away from a large wall. The speed of sound in air is 330 meters per second. How long after clapping does the student hear the echo?
This is simple. Your V is equal to 2D upon T. So T is equal to 2D upon V. How much is 2 into D? 2 into 100. Upon this is 330. So 20 upon 33. So 20 upon 33. Why do they give this? This is 0. Oh, 3 6 is 18, no?
0.61.
3 6 18 198. Yeah.
Consider the following statements related to sound. Statement 1. The wavelength of a wave is determined by the vibrating source that generates the sound.
Wavelength of the sound is determined by the vibrating source. Determined. And statement 2 is what?
The frequency of a wave is determined by the properties of the medium through which it travels.
Wavelength is determined. Now wavelength will depend upon the wave velocity. So we can find out wave velocity from the source of sound. It is doable. But the frequency, what determines the frequency? The source of sound. They are saying frequency is determined by the properties of the medium. No. Correct?
Yes, sir.
Frequency is determined by the size and shape of the sound, source of sound. Okay, so this is wrong. What is it? Statement 1 and 2 are correct. Both statement 1 and 2 are wrong.
Only statement 1 is correct.
Only statement 1 is correct. Only statement 2 is correct. Okay. The choices are a little different, no? Yeah. Okay.
Two devices are connected between 2 points, say A and B, in parallel. The physical quantity that will remain the same between the 2 points is.
Now, in parallel, what remains same? PD. Where is PD?
The temperature of a copper wire is increased at a steady rate. The graph best showing the variation of resistance is.
Okay, now remember it's a metal. If you increase the temperature, resistance is going to increase. Correct? This means it's decreasing, this means it's uniformly. This will be, it's a metal, no?
Yes, sir.
So it will be R, this one. A. It increases uniformly. What is next one?
The deflecting couple on the coil of the motor is minimum when A. Plane of the
Now, before you read this, let us understand. Deflecting couple, which means if this is the plane of the coil, the deflecting couple, that is the force over here, this will be maximum, and when it will be minimum, you will have the DC motor to understand. Now remember, the plane of the coil is parallel to the magnetic field, then deflecting couple is maximum, and when the plane of the coil becomes like this, then we'll have the, you see, this is the plane of the coil, and it will experience one force upward, one force downward, but they will be in one line only. So the rotation will be zero. Do you understand?
Yes, ma'am.
So how will you describe this position? The plane of the coil is perpendicular to the magnetic field. The molecules of a substance in a particular state of matter move freely with random motion. The average speed of the molecules is increasing. What is being described? Average speed is increasing means kinetic energy is increasing, no?
Yes.
If the kinetic energy is increasing, the molecule of the substance in a particular state move freely in random motion.
A gas being heated.
So it is a gas, correct?
Yes.
It won't be the liquid, it won't be the solid. Did you understand this part?
Yes, ma'am.
Because freely they are moving, so it's a gas. And if the kinetic energy is increasing, we are heating it. So gas is being heated.
A solid at room temperature is heated. The graph shows how its temperature changes with time as it is heated constantly, at which time has it become completely liquid.
There is a solid, so this will be solid. This will be where the melting begins. This is where the melting will end at C. So at C it will be complete liquid.
Yes, ma'am.
Okay.
Different parts of the electromagnetic spectrum are used for different purposes. Below are 4 statements about parts of the spectrum. Statement 1: infrared rays are used in television remote controllers. Statement 2: ultraviolet radiations can be detected by a solution of silver chloride. 3: ultraviolet radiations are used for intruder alarms. 4: gamma rays are used for security checks.
Okay, now ultra UV radiations, they affect the silver chloride solution, correct? Is
Yes,
true.
ma'am.
Because the color changes from violet to brown to black, no? Brown to black, है ना? UV radiations are for intruder alarms. Intruder alarms is IR, if I'm not mistaken. And for security checks are X-rays, no, not gamma rays. Correct or no?
Yes. No.
Okay, so this is also wrong, and intruder alarm, this is also wrong. So which are the correct 1 and 2? So you can see what kind of questions are being asked. Oh?
Yes. Assertion: power of a convex lens is positive and that of a concave lens is negative. Reason: convex lens forms real image and concave lens forms virtual image.
Now the power, this is correct, but the reason is not because convex lens forms real image. It forms virtual image also, no?
Yes.
Why it is positive? Because the focal length is positive and here the focal length is negative. For convex it is positive focal length and focal length for this is negative. Now some of you will say that ma'am we don't quite understand this. So see, if this is the lens and if this is the incident ray coming from infinity, it will converge this way and this is the focal length. So this is on the positive side. Remember, in front of the lens means it is negative, correct?
Yes.
But let me change the color. If this was the uh, concave lens, it would have gone this way, and if we produce this backwards, then we will get on the negative side focal length, and power is equal to 1 upon f. So if focal length is negative, power will be negative, correct? So it is not because of real and virtual image. So what is our correct option?
C. Assertion is true but reason is false.
So we finish with question number 1. How many we finished? 15. So we collected 15 marks. Okay. Let us look at question number 2. Pendulum rises to maximum vertical height and it reaches its extreme position on one side. Mass of the bob is this. Acceleration due to gravity is this. Find total energy of the symbol pendulum at any instant. Now at any instant is the keyword. So you have to say at any instant will be equal to the potential energy at the extreme position by law of conservation of energy. Okay, and that will be equal to mgh. Is mass given? Yes. Is g given? Yes. Is h given? Yes. But can you see it is centimeter? So what we'll have to do? Make it into meter and get the value. Then the velocity of bob at its mean position. At mean position, all of the potential energy will get converted into kinetic energy, correct? So you will have v square is equal to 2gh. So that will be 2 into g, that is 10, into height is 5 upon 100. Okay, so your v will be equal to under root of that. Aren't you getting 100 upon 100? How is it?
Good.
Yeah, could do it, right?
Yes.
So this was for 3 mark, good enough. Now let us look at this. How is this? Do we have any problem with this? Tell me. What will 238 become after alpha? 234 here, and this will be 90. And if it is emitting gamma, then this will have to be in excited state and it will be B only, and this will remain the same. What is the mass number, atomic number? Easy. What will be the resulting nucleus? It will be the same, correct, but it will not be in an. The resulting nucleus means you have to tell mass number and the atomic number. Let us go fast because we are not having enough time to complete the whole paper. Define scattering of light, you can do on your own. Smoke from the fire looks white. Which of the following statements are true? Remember, the molecules of the smoke are bigger than the wavelength of light. Is correct?
Yes.
Okay. So remember, when it becomes white, if it is less, then all the colors are emitted to the same extent.
The wheel shown in the diagram has a fixed axle passing through O. The wheel is kept stationary under the action of 1. A horizontal force F1 at P, and 2. A vertical force F2 at Q.
Is this the question from the textbook? We have something similar to this. Quickly open the textbook. If it is the same, we have already solved this. See, this is going to give you the clockwise movement and this one is going to give you uh, this way, anti-clockwise movement. Can you see that? Yeah. So what will be the moment due to F1? What are they saying?
Ma'am, it's on page 7. Solved example.
Solved example hai na?
Yes, ma'am.
Yeah. So what are they telling? Find the ratio between the forces F1 and F2. So remember your uh, F1 multiplied by this PO, that is OP, will be equal to F2 multiplied by this distance O dash O. Okay, because you will say at equilibrium by principle of moments, correct or no?
Yes, ma'am.
Or you can say that the torque due to F1 is equal to, because it's in balance condition, so torque due to F1 equal to torque due to F2. Okay, and after you get this, you will have F1 upon F2. Find the ratio between the forces F1 is to F2 will be equal to O dash O upon OP. Now can you see all these measures are given? You can follow this on your own and you can get it. Understood? We are not going to do each and every step. Let us come to this. Why does ice cream at 0 appears to be colder than water at 0 degrees C? Here you have to remember to write the mass, the temperature during change of state, everything should be done properly. This is the question for which I have given you the answer already. Let us move to the sixth one. Rear view mirror of the motorbike bike starts vibrating violently at a particular speed. Why does it happen?
Due to resonance.
Name the phenomenon resonance, and this also resonance. How will we say that? This is so as to, come on, let us write this. This is so as the frequency of vibration of engine of motorcycle at that speed, at double underline that speed, into bracket external periodic force equals, double underline, equals the natural frequency of vibration of rear view, underline natural frequency of rear view mirror okay, then the name of the phenomenon, resonance. Okay, actually in the first part you can also say, therefore due to resonance the rear view begins to vibrate with larger amplitude. And then you can just write resonance as the name of the, name the material used for making control rods, cadmium. Why is this material named by you suitable? Because cadmium absorbs extra neutrons. Okay, so this is there in your nuclear physics. Let us come to question number 3. Okay, the diagram has been given here. Copy the diagram, mark the arrows of light after reflection from the mirror, name the principle you have used to mark the arrows. Now this one is again from your textbook. If it is incident this way, it will go this way and it will get reflected like this, correct?
Yes.
What are they telling you to do? Name the principle. Principle of reversibility. Okay. Now look at this one. What's the relation between refractive index of water with respect to air? So A mu W and the refractive index of air with respect to water. So this is very simple. They are reciprocals, yes?
Yes, ma'am.
Yes, ma'am.
This is pretty simple. If refractive index of water with respect to air is this, then what is it with respect to water? This will be equal to 3 upon 5. Okay, now 3 upon 5 you have to write it as 0.6. This was the tricky part. If you don't put it in decimal, you will lose that 1 mark. Don't write it as a fraction. So that was pretty simple. Equal masses, two boxes having uniform velocity v and 3v. Find the ratio of the kinetic energy. This is simple.
Yes,
Ke1 is to Ke2 will be equal to half m1 v1 square is to half m2 v2 square. Okay, then this and this gets cancelled. The mass is the same, so m v square, and here it will be m and 3v whole square. M got cancelled and you'll have v square is to 9v square, and you'll get your answer as 1 is to 9. Okay. A cell supplies current of blah through 2 ohm coil and this thing through 8 ohm coil. Calculate the internal resistance of the cell. How's it? Say don't like it.
No, I don't like it.
You don't like it. Doesn't matter. There is a cell. Show the cell. Okay. It is going through 2 ohm and the current it supplies is 0.6 ampere. So let us call this as R1 and let us call this as I1. And here we'll do exactly the same thing. And this is 8 ohm and this one current over here is 0.3 ampere. Okay, this will be your I2 and this will be your R2. Okay, now we know that I1 will be equal to E upon R1 plus R. So 0.6 is equal to E upon 2 plus R. Correct? So E is equal to 0.6 into bracket 2 plus R. Now looking at this, tell me, what should I write here? Come on, I2 equal to what? E upon
R2 plus R.
Very good. So 0.3 is equal to
0.6
E upon
up
0.6 कैसे आया यहाँ पे?
0.6 into 2 plus R.
What is R2?
8.
So what are you telling me?
No, instead of E we can write 0.6 into 2 plus R.
Quietly do exactly the same thing. Okay? You don't complicate the issue. I've seen your work. You are missing the steps and complicating the things and losing marks. Okay? Just now I checked your work, no?
Yes,
So now E is equal to what? 0.3 into bracket 8 plus R. I'm not interested in E equal to blah, E equal to blah. So you will say therefore E equal to 0.6 into 2 plus R, and that's equal to 0.3 into bracket 8 plus R. Okay. Now I can do this 3 ones and 3 twos. So I'll have 4 plus 2R is equal to 8 plus R. Can you find now? How much is smaller?
4 ohm.
Mila, now understood?
Yes, sir.
Okay. Now this one, isn't this something similar to what we have in the textbook? Are you okay with this or no? How many of you don't like this question? Is there anyone who doesn't like this?
Ma'am, I don't like it.
Okay, can you quickly read this?
In the diagram of a stationary wheelbarrow, the center of gravity is at A. The wheel and the leg are in contact with the ground. The horizontal distance between A and F is 50 centimeters, and that between B and F is 150 centimeters. The weight of the wheelbarrow is 15 kgf and it holds sand of weight 60 kgf. Calculate the minimum force required to keep the leg just off the ground.
Okay, now where is the effort applied? Here, no?
At B.
Okay, minimum effort. You want minimum effort means it will have to be maximum distance here. Understanding?
Yes, ma'am.
Okay. Now tell me one thing. What is the load arm? Where is the load arm? This is from load. This is the fulcrum, correct? Load arm is what? 50. And what is the effort arm? Tell fast. How much is the effort arm?
100 centimeters.
Effort arm is from year to year, no? How it is 100?
150 centimeters.
How it is 100? It is 100 plus 50. Correct or no?
Yes, sir.
Yes, ma'am.
Now tell me, mechanical advantage is load upon effort, but if it's a lever, it is also EA upon LA, correct?
Effort same upon load arm.
Ah, so load is how much? How much is the load?
60 kg.
75 kgf, baby. Total, no? Yeah. And how much is the effort? We have to find that. How much is effort arm? Tell me. 150 centimeter. Upon what?
50 centimeters.
So effort is equal to 75 upon 3 means
kg.
25 kg.
Sorry.
was this so bad?
No.
It wasn't so bad, right? Now remember that from the fulcrum to the effort is the effort arm, not this. Alright? Understood? What type of lever this is? Load between fulcrum and effort means?
Class 2.
Class 2 lever, and mechanical advantage will always be more than. Now see, a diver in the water looks obliquely at, so this is the diver. Does the object appear taller or shorter? It will be, see, remember in the denser medium, the fish comes closer, the bottom of the tank appears to be up, the tank looks shallower, correct or no?
Yes, sir.
It appears to be raised, correct or no? The postage stamp at the base of the glass slab appears to be raised.
Yes, sir.
That means the apparent depth in the of the object inside Remember that if the fly is looking at the fish, fish looks closer, but the fish looks at the fly will look above. Understanding? So the object appears taller or shorter or same size to the diver. Diver is here, no? Diver is in the denser medium. So here it will be writing taller.
Taller.
Okay? Hello?
Yes, ma'am.
Okay. Now copy the diagram and show the path of two rays. Now when you're drawing the diagram, don't copy it like this. Copy it this way. This is your diver somewhere here. But what you do is, let me just take a straight line. What you do is, first of all, take the reference. Do I need the reference line? Yeah. This is the object over here. This is your A, point A, and this is your point B. Okay. Now, you will take any two rays this way and this way. Just take any two rays. Can you do that?
Yes.
Show the normal. Okay. Now tell me, it goes into the denser medium, so it is going to turn towards the normal, yes?
Yes, ma'am.
So when it is turning towards the normal like this, it is going to appear to be coming from here. So we will need the reference line. Oh dear me. Okay. I'll just cancel this. I'll just tell you where I went wrong. You show first the reference line. Okay. And the object is going to be taller, so make that object up to here only. Understanding?
Yes, ma'am.
Don't take itta uncha, because then the diagram will not fit on the page. And when you take these rays, they are going to go towards the normal, so make sure that these two rays are like this nicely. You understood how you should take the rays? You are understanding what I'm doing? Hello?
Yes, ma'am.
Okay, so that was my mistake. I copied them like this only with the kind of angles they have shown. And then the image was not fitting in the diagram, space available for the diagram. Okay, now imagine that the ray is going to meet somewhere there and show this. Can you see what I've done? Now when you are drawing this, draw this dashed and then this straight. Okay, then from here the same point take. This part will be dashed. Understanding? Now I'm going to show it as dashed. See, this is how I will show dashed, because I cannot do dash dash dash. I have to show it like this. Understood? So this is your A, this is your B, and this will be your A dash. All right. Now the eye of the diver, can you see the diver's eye will be that big? We'll have to exaggerate the size of the, okay, label this as eye of diver. And don't just show one stupid eye like this. The other ray is not going into the diver's eye. So don't show like that. Understanding, na kiddos?
Yes, ma'am.
Yes, ma'am.
So this is your object and this is your image. Now understood?
Yes, ma'am.
So this is your C and this is your D. So if you were to take like this with more angle over here, like this. See, I have taken lesser angles over here. So I have a bigger angle of incidence here and bigger angle of incidence. If I were to take a normal here, small angle milta hai. Then I can't show the visible turning of the ray. Understanding?
Yes, ma'am.
Why this ray is not going into the eye? Why it is floating? Let it go in the eye. See, you don't be careless. If you are careless, what will happen? Your teacher will just slash your marks. Can't be careless. Okay?
Yes, ma'am.
Now tell me, object is placed at a distance of this, so u is equal to minus 24 centimeter, convex lens, so the focal length is going to be positive. Positive what? 8 centimeter. Calculate the distance, you can do this, and calculate the magnification. What is the formula? 1 upon f is equal to 1 upon v minus 1 upon u. Can you proceed with this?
Yes, ma'am.
You can do this on your own. This will be 1 upon 8 and this will be like this, and minus 1 upon minus 24, and then pause over there and write this once again. Don't do this mentally. Understanding? And calculate the magnification. What is magnification going to be equal to? I upon O, which is going to be equal to V upon U. Now tell me, if it is at 24 centimeters, it is more than the focal length, correct?
Yes.
So it's going to be a real image. When it is real image, your V will be positive, correct? Upon U will be negative. So your magnification will be minus something. Understood what I'm saying? Can you handle this on your own? Tell me.
Yes.
Can I move to the next one?
Yes, ma'am.
Now they are telling you, copy the diagram and use 3 rays starting from A. Can you find 3 rays? Now this has to be slightly bigger when you are drawing. It is going to be here. So one ray will be this way. The second ray will be like this. Understanding?
Yes,
and the third ray. How can you take 3 rays? They are saying 3 rays starting from point A.
We can
So
take
you
A
can
as
take
the
this.
focal length and then we can make it parallel from the.
See, this is how. This is how you will have to take from F. But then can you see this lens will have to be a little longer.
Okay.
Okay, and then it will come like this. And all 3 rays have to meet at the same point. Okay, make sure that you show at each point you have to show the arrows. If you don't show the arrows, it's going to be tough. Can we move to this question? Which of the remaining constant for uniform circular motion? What remains constant for uniform circular motion?
Speed.
The speed remains.
Speed.
Velocity changes at every point, correct? Name the force required for uniform circular motion is centripetal force. The direction is radially towards the center. Okay, so these are easy. Man having box on the head climbs up the slope. Another man, identical box, walks the same distance on the level road. Which does more work against the force of gravity and why? Now remember, the person who is climbing will do the work, but the person who is going on the level road like this, against the force of gravity, the theta is going to be 90 degrees, and then you say W is equal to Fs cos theta, which is Fs cos 90, which is Fs into 0. Okay? A body is thrown vertically upwards, velocity keeps on decreasing. What happens to its kinetic energy as the velocity becomes 0? Kinetic energy gets converted into potential energy.
Potential.
Correct or no? And the maximum potential energy. So this was for 1 mark, this was for 2 marks. So this is kind of relatively easy questions. We can go fast with these, okay? Now what are they telling you? Having velocity ratio 3 means what you will say? Velocity ratio equal to number of pulleys, correct? No?
Number of strands.
Number of strands. So upper block will have 2
2.
and the lower block will have
1.
1. Now when you are drawing, let me just make it quick. If you want, you can show this, but show with a schematic diagram only. Show one hook and show over here itta bada gap. Okay, don't take it very close to it, and this one, and show a hook here. And when you show the load, some of you show the load so tiny. From the center of gravity, you have to show the center of gravity and then show this is the load. When they ask you diagram, don't just write L. Please write load. And then if you want, write L. Understood? Then you have to start with this. Go this way. Sorry. Alright. And show T, T, T everywhere. This is T, 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 T. And this is E, means effort. And write into bracket E. Okay, then label this as upper block. Label this as lower block. What you label this as? Rigid surface. Okay, this much has to be done for getting your full 2 marks for this diagram. The pulley system lifts the load of blah when the effort of 60 Newton is applied. So what is the mechanical advantage? Load upon effort means 150 Newton upon 60 Newton. So this will be 3 2s and 3 5s. So it is 2.5. Is the above pulley an ideal machine or not? Definitely not ideal machine. Why? Because VR is equal to 3 and MA is equal to 2.5. Correct?
Yes.
Therefore, what is my efficiency? MA upon VR into 100%, which means it is 2.5 upon 3 into 100%, and which is 250 upon 3%, which is 83.33%, which is less than 100%. Okay, now if you write like this, your teacher cannot cut your mark. Don't say because mechanical advantage is less than VR, that is why. Don't just write like this. Okay, show that efficiency is less than 100% also. Understood, no? How to make sure that your teacher gives you full marks? Yes?
Yes.
Okay. Now what are they saying over here? The 24 volt is the EMF, a negligible internal resistance. Okay. So R equal to 0 is there. Find the reading of the ammeter. This will be, first you will find RP. Correct? RP. Yes?
Yes.
And then add this and this. And then you will say I is equal to V upon R. कर सकते हैं, tell fast. That will be I in circuit means reading of the ammeter. You can do this on your own, tell fast. And find the reading of this V1, V2. V1 will be equal to IR1. You're already finding out current, no? With the first part,
Yes.
the I into R1, and then this will be equal to I into R2, and this will be I into R3. You can handle this, tell fast. It's only for 3 marks, so it is not a difficult question. Can we move to the next one?
Yes.
Why is it dangerous to connect in neutral wire? Because when you switch off, even then what happens? The appliance will be
Connected to
connected to the high potential, है ना?
Yes.
And the person who will touch it will get a fatal shock. Draw the neat diagram of 3-pin plug. Name the pins. What did I tell you? Live on the left in the plug.
Yeah.
Correct or no? So in the plug on the left. So your plug will be plug will be like this. This will be the longer one. You have to show the split ends, and this way and this way. This will be shorter, this will be shorter. Live on the left, so this will be live, this will be neutral, and this will be earth. Show the splitted ends. Okay, properly. ठीक है?
Yes.
I have drawn very fast on this thing. The pump motor is used to deliver water. Draw the label diagram of the motor. Which is this motor? Which is this motor? कौन सा मोटर है? डीसी मोटर रहेगा ना? Yes or no?
Yes, ma'am.
Okay, it won't be the generator, right?
Yes,
Huh? Yeah. So they are telling you to draw the label diagram, and I have told you in 2 marks how to 2 minutes how to draw. Write out the principle on which the above motor works. What does it work on?
Principle of magnetic induction.
Magnetic induction, induced current है. When the current carrying conductor is placed in the magnetic field, it experiences the force. Check. It is not electromagnetic induction. And don't just say magnetic induction. Magnetic induction means what? Magnetism gets induced. So we are not having induced magnetism. Are we preparing electromagnet? No. So that is why. Okay.
Yes,
So now look at this. How is this? How is this?
good.
Free vibrations in vacuum and medium. Which one will be vacuum? A. Which one will be in medium?
B.
How did you conclude that? Because the amplitude is decreasing gradually, correct or no?
Yes.
Why does amplitude decrease? Since the energy is lost in doing the work to overcome
The
frictional force or resistive force offered by the surrounding medium. Correct? Nucleus contains no electron, but it can emit. How beta particle comes from? What you will say that one neutron splits into proton, and you remember one neutron gives one proton and one electron. Do you remember? Yeah, you remember this?
Yes.
So inside the nucleus there is neutron which splits into proton and electron. When does it happen? When the proton-neutron ratio, the neutron-proton ratio becomes more than 1, correct or no? That's the time one of the neutrons splits into proton and electron, and that electron is emitted as beta particle, correct? You remember that? A nucleus emits a beta particle and changes to Mg. This is simple. What will we say? Na23 is no 23, no, they've given it as 24, no?
Yes,
2411, it is going to become Mg. It will be here 24 and 11 becomes 12 plus 1 beta.
Na has 23, no?
It is an isotope of sodium, no?
Okay.
This is the radio isotope of sodium, huh?
Okay, ma'am.
Yeah, just like when I say carbon 14, normal carbon is 12,6, no?
Yes,
But if
ma'am.
it is 14,6, you can't say, oh ma'am, carbon has got 12, no? You can't say like that. This is the radioactive carbon, no? That's how.
Yes,
Okay,
ma'am.
understood. Now, what is the general name for this? Both of them have got the same atomic mass. Mass number is the same. So what are they? They are not isotopes, they are isobars.
But also bar.
Isobars. And then we have also isotones. What are isotones?
With the same mass number with different protons.
No. Isotones means same number of neutrons, which means A minus Z for the two atoms, they will be the same. Okay.
Yes,
ma'am.
ma'am.
Like for example, Na 2311 and Mg 2412. See, aren't you getting 12-year difference?
Yes, ma'am.
So these are isotones. Okay, understanding? You have to
Yes.
learn the you have to learn the definitions and the examples also properly. Okay. Okay, now 1 meter, 1 meter. Which one shows the principal note?
A.
One loop means principal note. It will have the maximum amplitude. Which one will be the loudest? A.
A.
Which one will be high pitch? This one.
B.
In which case the pitch will be higher? B. Give reason, since it has more frequency. Okay, and you see here, this will be frequency, this will be F, so this will be 2F. And in fact, FA is to FB will be equal to 1:2. They may ask you to compare even the wavelength. Okay, we have done some questions like this. What is this now? Wavelength. Can you see how they have given kilometers? Can you see
Distance,
kilometers?
distance.
What is this?
Distance.
Wavelength is given here. How distance?
Because sounds are missed, so V equals to.
Array Paggu Pillu, this is wavelength. When it is wavelength, how can you call it distance?
So then,
Read the question. A pulse is received after time interval this. Speed of the sound is this. Calculate the frequency. Now see, this is V, this is lambda, and this is the time. Can you see that? This is time. Yes. Now frequency. What is frequency? Frequency is equal to 1 upon time period. 1 second.
1
We,
upon
we can't use that. Wait. We have to use V is equal to
V
F
equals
lambda.
CF. Can use V equals to.
V is equal to F lambda. Okay.
Yes.
So 340 meter per second is equal to F into 8.5 into 10 to the power minus 6 kilometers. Kilometers into meters means e to 10 to the power 3 and make it meters. Understood what I did?
Yes, ma'am.
Yes, ma'am.
So what is frequency equal to? 340 meter per second upon 85, and I'm putting 10 upper, into 10 to the power minus 6. These many meters get cancelled, and then we will have 340.
Ma'am, but then it will be -3, right?
What did I do? I did something here. I said in my mind I'll put -3, and I did not write -3. Thank you. So 340 into 10 into 1000 upon 85. Correct? Now 85 will go 5 times, or you can say 17. 17 2s 34 and 17 5s. So 5 1s and 5 4s. So I'm getting 4 and 40,000 per second means hertz. Okay, so this is the frequency. How's it, good, bad or ugly?
Good.
Now distance traveled by the pulse of the sound. So you are going to use, for the second part, you will say V is equal to total distance will be 2D upon T. Okay, so therefore you will have D equal to V into T upon 2. So that is 340 into time is 12 upon 100 into 2. So 2 ones and 2 goes 170 times, sorry, 0 0, I should have cancelled, no? 17 into 12. 12 sevens 84. Carry 8. 12 ones 12 and 8. So 20.4 meters. How's it, good, bad or ugly?
Good, ma'am.
Answer 2. Okay. Now we have to finish this paper fast. This is definition. Name the radioactive isotope for the age of fossil is carbon 14. Correct?
Yes.
Carbon 14 6. This diagram also, you know, the one which will go towards the negative will be alpha, and alpha will be going through a smaller angle, gamma will go vertical like that undeviated, and beta will go through larger displacement. Okay.
Yes.
Example of material:
Nichrome.
nichrome. Family uses fan, this that, for 8 hours daily. So you have to find the power consumed per day. No, sorry, energy consumed per day. So all of them are 8. So actually we can one light bulb, one fan, and one heater. So this is easy, no? So the power energy per
1200
day, energy per day will be P into T, okay, which will be 100 plus 100 plus 1000. So that is 1200 multiplied by 8 watts,
9600.
watt hour, upon 1000. So that will be kWh. Okay, cancel two zeros, cancel two zeros, and then multiply by 10. So the cost will be, it's simple, right? This multiplied by 12, it will be 96 rupees.
To 9.6.
Are they saying per day?
Yes.
Day only, no? Okay, sometimes if they tell you month, this also is
Multiply by
doable. If this is 30, this will be 60.
60.
Make sure that your diagram is like this, okay? Use the set square and have nice big diagram and do it properly the way I have told you. Okay?
Yes.
One difference between this is their learning work. What is this? Question number 9. Heat is supplied at a constant rate. The ice is converted to water in 5 minutes. How much time will it require to raise the temperature? This is a little time consuming. Let me just check. This is simple. This also is simple.
Yes.
Yeah, quantity of heat. And this is temperature. So the same quantity of heat, can you see A is showing higher temperature, so SHC is less.
Less.
Okay, can you see that?
Yes. Sir.
This with the same quantity of heat, this is giving shorter delta T. Okay, so this SHC is going to be more. Okay,
Yes.
then we come to 3 resistors connected together, equivalent resistance less equal to 4. Now 2 4 4. Now what is 4? 4 is equal to this and this, but it is more than this. So it will be 2 ohm plus 4 plus 4. Understanding? So it will be 2 ohm and 4 here and 4 here. And this is 4 and this is 4. Equivalent resistance will be 2. So this is 2, this is 2, it will be 4. Okay, now the only thing we have to do is this. This is going to be a little annoying for you. So there is the heater, so power and time, and this is ice.
Ice.
So ice, this is, and 400 grams of ice at 0. So ice at 0 degrees will become, mass is 400 gram, will become water at 0 degrees C, and that's it. That's it. At 0 degrees C, but it is taking 5 minutes. So this is 5 into 60 seconds. How much time will it require? Now using this MLF, you'll have to find the power. Okay, so for this you will say P into T, heat supplied by the heater, is equal to MLF. So P into 5 into 60 is equal to 400 into LF is given as 336. So power is equal to 400 into 336 divided by 5 into 60. So this 0 gets cancelled. 5 ones and 5 eights and 6 ones, and yeah, you could have done 300 also, yeah. So 6 fives and 6 sixes. How much are you getting?
448 watts.
448 watts you are getting.
Yes.
Now you are going to say again heater, and there is going to be now water. So water at 0 degrees to it's going to become water at 100 degrees C. That means MC delta T. And here power is 448 watts, and they are saying T2 equal to question mark. So again you will say P into T equal to what? MC delta T. So 448 into T is equal to 400 into 4.2 means 42 upon 10 into delta T is 100. So what are you getting? T equal to, I don't have space, I'm coming here. T equal to 400 into 420, no?
168000.
Don't multiply. 448. Okay, don't multiply please. Okay, so this is
Okay, ma'am.
4 goes 100 times, 4 goes 112 times. Okay, 7 will go 16 times, no? And 7 will go 60 times. Now don't touch this 60 because it will give me minutes directly. Okay, so 4 goes 25 times, 4 goes 4 times. So 25 upon 4 means 6 1/4, no?
Yes, sir.
6 1/4 into 60. These many seconds means it is 6 1/4 minutes. So either you can say it is 6.25 minutes, or you can make it into 6 minutes and 15 seconds. Understood?
Yes, sir.
Or you can write it as 6.25 minutes. Understood?
Yes, sir.
If they have given you in minutes, then you should also answer in minutes.
Yes.
Understood how this was done? So we finished the entire paper in record time, actually in just about 1 hour. What is normally given to you for 2 hours, we finished in about 1 hour, which is good. Okay, so I'm going to stop here.